Welcome to Tech with Kaushik. This is part 5 of our complete practice question series for the AZ-400 Microsoft Certified DevOps Engineer Expert exam. Choose your answer before the timer ends. Then review the correct answer, explanation, and exam tip. Let us begin part 5. Question number 174. Scenario. You are configuring Azure artifacts for an investment planning application suite. You need to assign appropriate package feed access levels to the developers and team leaders groups based on least privilege and common contribution requirements. Which package feed access levels should be assigned to the developers and team leaders groups? Drag the appropriate access levels to the correct groups. The available source items are as follows. Source item 1, collaborator. Source item 2, contributor. Source item 3, owner. Source item 4, reader. The destination requirements are as follows. Destination A, developers. Destination B, team leaders. The first correct mapping is contributor, map to developers. The second correct mapping is owner, map to team leaders. Here's why. In Azure Artifacts, the contributor role allows users to publish new packages to the feed, which is the standard requirement for developers. The owner role allows users to manage feed settings, permissions, and delete packages, which aligns with the elevated administrative requirements of team leaders. Exam tip. In Azure Artifacts, readers can download, collaborators can save from upstream, contributors can publish, and owners can administer the feed and delete packages. Question number 175. Scenario. An RBAC-enabled AKS cluster uses Helm 3. A team must prepare a namespace with the required Kubernetes RBAC objects, add the chart repository, and install a client application chart. Select and arrange the 3 required actions in the correct order. The available items are as follows. Item 1. Add and update the Helm chart repository. Item 2. Run Helm install for the application chart. Item 3. Run Helm init to deploy tiller. Item 4. Apply the namespace and RBAC manifest by using kubectl apply. Item 5. Run Helm serve to host a local chart repository. The correct sequence is as follows. First, apply the namespace and RBAC manifest by using kubectl apply. Second, add and update the Helm chart repository. Third, run Helm install for the application chart. Here's why. The namespace and RBAC objects must exist before the workload is installed. Helm must know the chart source before Helm install can deploy the release. Exam tip. Helm 3 has no tiller. Prepare Kubernetes prerequisites and chart access before installing the release. Question number 176. Scenario. An organization operates workloads in Azure and Azure Stack Hub. Several builds require custom Erlang and Hack toolchains that are not available on Microsoft-hosted images, and the jobs must access resources located in the Azure Stack Hub environment. Where should the organization run the Azure Pipelines build agents? The available options are as follows. Option A. On Microsoft-hosted agents. Option B. On self-hosted agents installed on Azure Stack Hub virtual machines. Option C. On developers' personal computers. Option D. On self-hosted Hyper-V virtual machines in a separate network with no route to Azure Stack Hub. The correct answer is option B, on self-hosted agents installed on Azure Stack Hub virtual machines. Here's why. Self-hosted agents can include unsupported custom toolchains and can be placed inside the Azure Stack Hub network to access local resources directly. Why are the other options not correct? A. Microsoft-hosted images do not guarantee the required custom toolchains or private Azure Stack Hub connectivity. C. Developer computers are not a controlled, scalable build platform. D. An isolated Hyper-V environment cannot reach the required Azure Stack Hub resources. Exam tip. Choose self-hosted agents when builds require private connectivity or software absent from hosted images. Question number 177. Scenario. A team requires a build to start automatically after code is committed to its repository. The pipeline administrator changes a release stage queue option to batch pending changes while a deployment is running, but does not configure a build CI trigger. Does this change meet the requirement? The available options are as follows. Option A, yes. Option B, no. The correct answer is option B, no. Here's why. A release queue option affects deployment behavior after builds exist. It does not create a continuous integration trigger that queues a build from a repository commit. Why are the other options not correct? A. The build pipeline still lacks a source change trigger. Exam tip. Build triggers start pipeline runs. Release queue settings control how completed builds are deployed. Question number 178. Scenario. A quality engineering team uses Azure DevTest Labs. Testers need a reusable definition that creates a Windows Server virtual machine from a selected marketplace image and automatically applies Google Chrome and Selenium artifacts. Which Azure DevTest Labs feature should the team create? The available options are as follows. Option A, a formula. Option B, a claimable virtual machine. Option C, a custom image containing only the operating system disk. Option D, an environment with no virtual machine definition. The correct answer is option A, a formula. Here's why. A DevTest Labs formula stores a reusable VM definition based on a base image together with size, settings, and artifacts such as Chrome and Selenium. Why are the other options not correct? B. A claimable VM is an existing shared machine, not a reusable creation definition. C. A custom image can capture software, but the requirement specifically fits a reusable base image plus artifacts definition. D. An environment without a VM definition cannot create the required test machine. Exam tip. Use a formula to standardize repeatable lab virtual machines from a base image plus artifacts and settings. Question number 179. Scenario. Developers use Azure DevOps to request feedback on a web application. Pilot users only run exploratory sessions in Chrome by using the Microsoft Test and Feedback extension. Permissions must follow least privilege. Select the minimum Azure DevOps access level required for each group. Complete each statement by selecting the appropriate option from its drop-down list. Statement 1. Developers who create feedback requests and manage the resulting work items require the blank access. The choices for Statement 1 are stakeholder or basic. Statement 2. Pilot users who only provide feedback through the extension require the blank access. The choices for Statement 2 are basic or stakeholder. For Statement 1, the correct selection is basic. Basic provides the development and work tracking capabilities needed to request and manage feedback. For Statement 2, the correct selection is stakeholder. Stakeholder is the least privilege access level for feedback-only participants. Exam tip. Give contributors basic access and use stakeholder for limited business or feedback participation when supported. Question number 180. Scenario. A multi-tier service uses Azure App Service and Azure SQL database. Operations must send application and database telemetry to one location, run ad hoc KQL queries to establish baselines, and create alerts when observed values exceed those baselines. Which service should be the central telemetry store and query platform? The available options are as follows. Option A, Azure Event Hubs. Option B, Azure SQL Database Intelligent Insights only. Option C, Application Insights without a shared workspace. Option D, Azure Monitor Logs with a log analytics workspace. The correct answer is Option D, Azure Monitor Logs with a log analytics workspace. Here's why. A log analytics workspace can centralize diagnostic data from App Service and Azure SQL, support ad hoc KQL analysis, and serve as the data source for Azure Monitor alerts. Why are the other options not correct? A. Event Hubs is an event ingestion service and does not provide the required KQL workspace and alert analysis experience by itself. B. Intelligent Insights focuses on Azure SQL diagnostics rather than centralizing both application and database telemetry. C. Application Insights alone is application-focused and does not by itself satisfy the shared cross-resource telemetry requirement. Exam tip. Use a log analytics workspace when multiple Azure resources must share KQL analysis and alerting. Question number 181. Scenario: a Java pipeline stores source in Azure repos and must publish build output as Azure DevOps server artifacts. Its Maven dependencies are hosted on an internal server that has no public endpoint. The proposed solution uses a Microsoft-hosted Ubuntu agent and adds the Java tool installer task to the pipeline. Does the proposed solution meet all requirements? The available options are as follows. Option A: no. Option B: yes. The correct answer is option A, no. Here's why. A Microsoft-hosted agent cannot reach an internal-only Maven repository unless the dependency is exposed through supported connectivity. Installing Java changes the toolchain, but does not provide private network access. Why are the other options not correct? B. The solution fails the private dependency access requirement even though the hosted agent can run Java tasks. Exam tip: tool installation does not solve network reachability. Use a self-hosted agent for private on-premises dependencies. Question number 182. Scenario: you are troubleshooting an issue with virtual machines managed by Azure Automation State Configuration. The machines are reporting configuration drift, but are not automatically remediating the changes. To resolve the current technical issue, what should you do to the register Azure RM Automation DSC node command? The available options are as follows. Option A: change the value of the configuration mode parameter. Option B: replace the register Azure RM Automation DSC node complete with register Azure RM Automation scheduled runbook. Option C: add the allow module overwrite parameter. Option D: add the default profile parameter. The correct answer is option A: change the value of the configuration mode parameter. Here's why. The configuration mode parameter of the local configuration manager, LCM, determines how the node handles configuration drift. Changing the value from apply monitor to apply and autocorrect ensures that the node automatically remediates drift to resolve the issue. Why are the other options not correct? B. Scheduled runbooks execute imperative scripts on a schedule. They do not configure the LCM for declarative DSC drift remediation. C. Allow module overwrite permits updating existing modules, which does not address the drift remediation behavior. D. Default profile sets the Azure credential profile, but does not change the node's DSC enforcement behavior. Exam tip: to automatically correct configuration drift in Azure Automation State Configuration, ensure the LCM's configuration mode is set to apply and autocorrect. Question number 183. Scenario: a platform team uses an Azure pipeline to deploy a database environment. The parent ARM template must invoke a child template stored in a secured artifact location. The child deployment receives a secret by referencing an Azure Key Vault resource ID generated at deployment time. Complete the ARM resource declaration by selecting the appropriate value for each blank. Complete each statement by selecting the appropriate option from its drop-down list. Statement 1. The resource type for the nested deployment must be the blank. The choices for Statement 1 are Microsoft resources/deployments, Microsoft.keyvault/vaults, or Microsoft resources/template specs. Statement 2. The property that identifies the external child template must be the blank. The choices for Statement 2 are template link, template, or deployment. For Statement 1, the correct selection is Microsoft resources/deployments. This resource type creates a nested or linked ARM deployment. For Statement 2, the correct selection is template link. Template link references a child template through an external URI. Exam tip: use template for inline nested content and template link for a child template retrieved from another location. Question number 184. Scenario: a software company scans dozens of Node.js repositories by using a legacy white source integration. Each repository contains package.json and dependency lock files. The security team wants the generated inventory to contain only dependencies declared directly by developers, rather than the complete resolved dependency tree. Which scanning approach should the DevOps engineer configure? The available options are as follows. Option A: scan the installed node_modules directories by using the file system scanner. Option B: use package.json as the authoritative manifest and exclude dependency lock files from the scan. Option C. Publish every dependency to an artifact repository before running the scan. Option D. Add all development packages to the dependencies section of each lock file. The correct answer is option B. Use package.json as the authoritative manifest and exclude dependency lock files from the scan. Here's why. Package.json expresses the packages declared directly by the project. Dependency lock files represent the fully resolved graph and can cause transitive packages to appear in the inventory. Why are the other options not correct? A. Scanning node_modules discovers installed direct and transitive libraries. C. Moving packages to an artifact repository does not limit the dependency graph reported by the scanner. D. Adding more entries to a lock file increases or changes the resolved dependency inventory rather than limiting it to direct declarations. Exam tip. A package manifest records declared dependencies. A lock file normally records the complete resolved dependency graph. Question number 185. Scenario. An Azure pipeline must deploy reviewed database schema changes to an existing Azure SQL database. The pipeline uses the Azure SQL database deployment task, and the application data must remain in place. Which build artifact should the pipeline deploy? The available options are as follows. Option A. A database backup file. Option B. A backpack file. Option C. A DACPack file. Option D. An MDF data file. The correct answer is option C. A DACPack file. Here's why. A DACPack contains a declarative database schema model that the Azure SQL deployment task can compare with and publish to an existing database. Why are the other options not correct? A. A backup file is used for database restore operations, not model-based schema publishing. B. A backpack contains schema and exported data and is primarily used for import or export. D. An MDF file is a SQL Server data file and is not the deployment artifact expected for Azure SQL schema updates. Exam tip. Use DACPack for schema deployment and backpack for logical database import or export. Question number 186. Scenario. A product team is designing an Azure DevOps dashboard to measure work item flow and sprint progress. Drag each applicable Azure Boards widget to the measurement it represents. A widget may remain unused. The available source items are as follows. Source item 1. Cycle time. Source item 2. Velocity. Source item 3. Burn down. Source item 4. Lead time. The destination requirements are as follows. Destination A. Time between creation of a work item and its completion. Destination B. Time between the start of active work and completion. Destination C. Trend of work that remains unfinished. The first correct mapping is cycle time, mapped to time between the start of active work and completion. The second correct mapping is burn down, mapped to trend of work that remains unfinished. The third correct mapping is lead time, mapped to time between creation of a work item and its completion. Here's why. Lead time measures the entire wait and delivery interval. Cycle time starts when work becomes active. A burn down chart shows how much planned work remains. Exam tip. Lead time begins when work is requested. Cycle time begins when active work starts. Question number 187. Scenario. An engineering organization frequently hires developers. Administrators plan to use Microsoft intragroups, Azure DevOps group rules, and AP is to automate user onboarding and access level assignment wherever possible. Which activity still requires a commercial or administrative action outside the automated onboarding workflow? The available options are as follows. Option A. Adding new developers to the Azure DevOps organization. Option B. Assigning access levels through group rules. Option C. Updating Azure DevOps security group membership. Option D. Purchasing or enabling the required paid user capacity. The correct answer is option D. Purchasing or enabling the required paid user capacity. Here's why. User creation, group membership, and access level assignment can be automated through Microsoft Intra integration, group rules, or Azure DevOps APIs. Establishing billing or purchasing paid capacity remains an administrative commercial action. Why are the other options not correct? A. Users can be added programmatically or through group-based membership. B. Group rules can assign access levels automatically. C. Security group membership can be managed through directory groups and automation. Exam tip. Separate automated entitlement assignment from the billing or purchasing process that provides paid access. Question number 188. Scenario. A Java development team uses Maven in Azure pipelines. Reviews reveal unused local variables, empty exception handlers, and other code quality defects. The team wants these issues detected during continuous integration. Which pipeline configuration should the team implement? The available options are as follows. Option A. Enable expertise output for an Xcode task. Option B. Publish JavaCoco code coverage results. Option C. Run PMD as part of the Maven build. Option D. Run only checkstyle formatting validation. The correct answer is option C. Run PMD as part of the Maven build. Here's why. PMD performs static analysis of Java source and includes rules for defects such as unused variables, empty catch blocks, and other maintainability problems. Why are the other options not correct? A. Expertise formats Xcode build output and does not analyze Java code. B. JavaCoco measures code coverage rather than detecting these static analysis defects. D. Checkstyle primarily enforces coding conventions and formatting rules. Exam tip. Use PMD for Java defect patterns, checkstyle for style rules, and JavaCoco for code coverage. Question number 189. Scenario. A consulting company is creating 3 Azure DevOps projects with different work tracking requirements. Drag the most appropriate inherited process to each project. One process may remain unused. The available source items are as follows. Source item 1, CMMI. Source item 2, Basic. Source item 3, Scrum. Source item 4, Agile. The destination requirements are as follows. Destination A, track product backlog items and bugs on a Kanban board, and decompose backlog items into tasks. Destination B, track user stories, bugs, and tasks by using Agile work item terminology. Destination C, track formal requirements, change requests, risks, and reviews. The first correct mapping is CMMI, map to track formal requirements, change requests, risks, and reviews. The second correct mapping is Scrum, map to track product backlog items and bugs on a Kanban board, and decompose backlog items into tasks. The third correct mapping is Agile, map to track user stories, bugs, and tasks by using Agile work item terminology. Here's why. The Scrum process uses product backlog items. Agile uses user stories. CMMI provides formal work item types including requirements, change requests, risks, and reviews. Exam tip. Identify Azure Board's processes by their default backlog item. Scrum uses PBIs, Agile uses user stories, and CMMI uses requirements. Question number 190. Scenario. A team has an existing Git repository hosted on GitHub. A new empty Git repository has been created in Azure repos, and the complete source history must be copied into it. What should the team use? The available options are as follows. Option A. Configure a GitHub service hook. Option B. Open a pull request between the two services. Option C. Use the import repository operation in Azure repos. Option D. Create an Azure DevOps service connection without importing the repository. Option E. Generate an Azure DevOps personal access token only. The correct answer is option C. Use the import repository operation in Azure repos. Here's why. The Azure repos import operation clones an existing Git repository and its commit history into the new Azure repos repository. Why are the other options not correct? A. A service hook sends event notifications and does not copy repository history. B. Pull requests merge branches within a compatible repository workflow and are not a repository import mechanism. D. A service connection authorizes integration but does not perform the import. E. A personal access token can authenticate an operation but does not itself migrate the repository. Exam tip. Use repository import for an initial Git migration. Use service connections for ongoing pipeline integrations. Question number 191. Scenario. Developers create short-lived feature branches in Azure repos. The main branch receives many pull requests, and the team wants each completed pull request represented by one commit instead of retaining every intermediate feature branch commit. Which merge strategy should the branch policy permit? The available options are as follows. Option A, no fast-forward merge. Option B, squash merge. Option C, rebase and fast-forward. Option D, fast-forward merge. The correct answer is option B, squash merge. Here's why. Squash merge combines the changes from all commits in the pull request into one new commit on the target branch, producing a concise main branch history. Why are the other options not correct? A, no fast-forward merge preserves the branch's individual commits and adds a merge commit. C, rebase and fast-forward replace and retains the individual commits. D, fast-forward merge advances the branch pointer without consolidating all changes into one commit. Exam tip. Choose squash when each pull request must appear as one commit in the target branch. Question number 192. Scenario. A mobile development team is migrating its Android and iOS app distribution workflow from the retired Visual Studio App Center to a currently supported platform. The new solution must integrate closely with Azure pipelines and support distributing pre-release builds to specific groups of testers across both operating systems from a single service. Which service should the team configure to distribute the pre-release builds? The available options are as follows. Option A, Azure Artifacts. Option B, Firebase App Distribution. Option C, Azure Test Plans. Option D, Azure Deployment Environments. The correct answer is option B, Firebase App Distribution. Here's why. Following the retirement of Visual Studio App Center, Microsoft officially recommends migrating cross-platform pre-release app distribution to Firebase App Distribution, or alternatively using Apple Test Flight and Google Play Console natively. Firebase integrates seamlessly with Azure pipelines for automating beta releases to targeted tester groups. Why are the other options not correct? A, Azure Artifacts is used to host and share software packages like NuGet, NPM, and Maven, not to distribute mobile app binaries to test devices. C, Azure Test Plans manages manual and automated test cases and execution tracking, but does not host or distribute mobile application binaries. D, Azure Deployment Environments provides self-service cloud infrastructure provisioning, which is entirely unrelated to mobile application testing. Exam tip. For modern mobile CI/CD and Azure DevOps, use Firebase App Distribution for cross-platform beta distribution or native store pipelines. TestFlight/Google Play for platform-specific tracks. Question number 193. Scenario. A delivery team wants an Azure pipeline to launch browsers, interact with pages, and validate the user interface of a web application. Which testing framework should the team integrate? The available options are as follows. Option A, Microsoft Code Analysis. Option B, Jaco. Option C, Xamarin.uitist. Option D, Selenium. The correct answer is option D, Selenium. Here's why. Selenium automates web browsers and supports end-to-end interaction with web application user interfaces. Why are the other options not correct? A, Microsoft Code Analysis provides compiler and code analysis APIs. B, Jaco collects Java code coverage information. C, Xamarin.uitist targets mobile application UI testing rather than browser-based web testing. Exam tip. Associate Selenium with web browser UI automation and Xamarin.uitist with legacy mobile UI testing. Question number 194. Scenario. Every pipeline in an Azure DevOps project requires access to application secrets held in Azure Key Vault. Secret values must remain in the vault and must not be entered directly into pipeline definitions. What should the DevOps engineer configure? The available options are as follows. Option A, upload the secrets as Azure Pipeline secure files. Option B, create a variable group linked to Azure Key Vault. Option C. Grant every pipeline permission to edit project security. Option D. Store the values as ordinary project variables. The correct answer is option B. Create a variable group linked to Azure Key Vault. Here's why. A Key Vault linked variable group lets multiple pipelines retrieve authorized secrets at runtime without copying their values into pipeline definitions. Why are the other options not correct? A. Secure files protect file-based assets and are not the appropriate mechanism for ordinary Key Vault secrets. C. Pipeline security permissions do not provide runtime secret retrieval. D. Ordinary project variables would store the secret values in Azure DevOps instead of retaining them in Key Vault. Exam tip. Link a variable group to Key Vault when several Azure pipelines need centrally managed secrets. Question number 195. Scenario. The main branch of an Azure repos repository has mandatory build validation. One release manager must be able to complete an emergency pull request when validation fails, but the manager must not receive broader project administration privileges. Which configuration follows the principle of least privilege? The available options are as follows. Option A. Add the manager to project administrators. Option B. Grant the manager build administrator permissions. Option C. Grant the manager repository-wide policy editing permissions. Option D. At the main branch scope, allow the manager to bypass policies when completing pull requests. The correct answer is option D. At the main branch scope, allow the manager to bypass policies when completing pull requests. Here's why. The branch-scoped bypass permission allows the specified user to override pull request policies for that branch without granting broad project or repository administration rights. Why are the other options not correct? A. Project administrators grants substantially more privilege than required. B. Build administrator permissions manage build resources and do not bypass branch policies. C. Repository-wide policy editing access is broader than a branch-scoped completion bypass and permits policy modification. Exam tip. For emergency merges, grant bypass policies when completing pull requests at the narrowest branch scope. Question number 196. Scenario. A deployment pipeline must create 2 Azure resource groups and then provision compute resources in one group and databases in the other. For the statement, select yes if the proposed design satisfies the requirement. Otherwise, select no. Statement 1. A single subscription scope bicep entry point can create both resource groups and invoke modules scoped to the appropriate resource groups. Statement 1. A single subscription scope bicep entry point can create both resource groups and invoke modules scoped to the appropriate resource groups. The answer is yes. Subscription scope orchestration supports resource group creation and nested module deployments to multiple resource groups. Exam tip. Use subscription scope to create resource groups, then deploy group-level resources through scoped modules or nested deployments. Question number 197. Scenario. A team develops an internal NuGet package that must be centrally versioned and available to all developers through Visual Studio. New package versions will be published by an Azure pipeline. Which 3 actions should the team perform? Select exactly 3 answers. The available options are as follows. Option A. Add the Azure Artifacts feed as a NuGet package source in Visual Studio. Option B. Commit the compiled package to an Azure repos Git repository. Option C. Create an Azure Artifacts feed. Option D. Add the package address to Visual Studio environment variables. Option E. Publish the NuGet package to the feed. Option F. Create a separate Git repository for each package version. The correct answers are Option A. Add the Azure Artifacts feed as a NuGet package source in Visual Studio. Option C. Create an Azure Artifacts feed. And Option E. Publish the NuGet package to the feed. Here's why. The feed provides centralized package storage and versioning. Publishing places package versions in the feed, and configuring the NuGet source allows Visual Studio users to discover and consume those versions. Why are the other options not correct? B. Git repositories are not a substitute for a version NuGet feed. D. Visual Studio environment variables do not configure a NuGet package source. F. Package versions belong in the feed and do not require separate repositories. Exam tip. A complete package management workflow needs a feed, a publishing step, and consumer package source configuration. Question number 198. Scenario. A Java build must restore dependencies from a Maven repository available only on the corporate network. Source code is stored in Azure repos, and build outputs must be published as Azure pipeline artifacts. For the statement, select yes if the proposed design satisfies the requirements. Otherwise, select no. Statement 1. Run the build on a Microsoft-hosted agent and install the required Java version during the job. Statement 1. Run the build on a Microsoft-hosted agent and install the required Java version during the job. The answer is no. The agent can obtain Java, but it cannot reach the private on-premises dependency service without suitable private connectivity. Exam tip. Choose a self-hosted agent when a build must reach systems that are accessible only from a private network. Question number 199. Scenario. A mobile application team uses Azure pipelines to automate Android and iOS releases. After moving away from legacy third-party distribution tools, the team now configures distribution tracks for different testing audiences using native Apple and Google Store integrations. Drag the appropriate platform distribution method to each tester population. The available source items are as follows. Source item 1. Apple Test Flight External Testing. Source item 2. Google Play Internal Testing. Source item 3. Apple Test Flight Internal Testing. The destination requirements are as follows. Destination A. A small group of trusted Android QA testers who need immediate access to early builds. Destination B. Up to 10,000 iOS beta testers who access the build via a public link or email invitation. Destination C. A small group of registered iOS development team members who test early builds. The first correct mapping is Google Play Internal Testing, mapped to a small group of trusted Android QA testers who need immediate access to early builds. The second correct mapping is Apple Test Flight External Testing, mapped to up to 10,000 iOS beta testers who access the build via a public link or email invitation. The third correct mapping is Apple Test Flight Internal Testing, mapped to a small group of registered iOS development team members who test early builds. Here's why. Native Store distribution tracks offer specific tiers of testing. Google Play Internal Testing pushes Android builds quickly to a limited list of trusted users. Apple Test Flight Internal Testing is restricted to the App Store Connect team, while external testing supports large beta audiences via public links or invites. Exam tip. Understand the native testing tracks available in Azure DevOps Store tasks. Internal, alpha, beta tracks for Google Play, and internal/external testing for Apple Test Flight. Question number 200. Scenario. A repository in Azure DevOps must start a build automatically whenever developers push code to the integration branch. For the statement, select yes if the proposed configuration satisfies the requirement. Otherwise, select no. Statement 1. Enable a pull request trigger in the classic release pipeline. Statement 1. Enable a pull request trigger in the classic release pipeline. The answer is no. The setting applies to release behavior for pull requests and does not provide push-based continuous integration for the build pipeline. Exam tip. Configure CI triggers on the build pipeline. Release and pull request triggers serve different lifecycle events. Question number 201. Scenario. A security engineer is configuring Microsoft Defender for Cloud DevOps Security to centralize security posture management for Azure DevOps and GitHub environments. Evaluate each statement regarding Defender for Cloud DevOps Security. Select yes if the statement is true. Otherwise, select no. Statement 1. Defender for Cloud DevOps provides a unified view of code and dependency vulnerabilities across both GitHub and Azure DevOps. Statement 2. Integrating GitHub with Defender for Cloud DevOps requires a classic personal access token, PAT, rather than a GitHub app. Statement 3. Defender for Cloud DevOps can enforce pull request annotations directly from Azure DevOps pipeline security scanning results. Statement 1. Defender for Cloud DevOps provides a unified view of code and dependency vulnerabilities across both GitHub and Azure DevOps. The answer is yes. Defender for Cloud centralizes security posture for multiple supported platforms. Statement 2. Integrating GitHub with Defender for Cloud DevOps requires a classic personal access token, PAT, rather than a GitHub app. The answer is no. Microsoft recommends and uses the Defender for Cloud GitHub app for the integration. Statement 3. Defender for Cloud DevOps can enforce pull request annotations directly from Azure DevOps pipeline security scanning results. The answer is yes. PR annotations are a native capability to provide immediate developer feedback. Exam tip. Defender for Cloud DevOps security centralizes posture management and uses modern app-based integrations rather than user-bound PATs where supported. Question number 202. Scenario. A development team is working on the investment planning application suite. Developers must be able to work on new capabilities independently without affecting the main code base until their work is fully validated. Which branching strategy should you recommend for the investment planning application suite? The available options are as follows. Option A, release isolation. Option B, main only. Option C, development isolation. Option D, feature isolation. The correct answer is option D, feature isolation. Here's why. Feature isolation, feature branching, allows developers to work on new capabilities in dedicated branches. This keeps the main code base stable and deployable while new features are developed and tested independently. Why are the other options not correct? A. Release isolation creates separate branches for stabilizing specific releases rather than isolating individual features during active development. B. A main-only strategy forces all developers to commit to a single branch, which conflicts with the requirement for independent, isolated development. C. Development isolation is a broader environment or infrastructure concept, whereas feature isolation specifically addresses the branching model. Exam tip. Use feature isolation, feature branches, when developers need to work on new capabilities independently without destabilizing the main integration branch. Question number 203. Scenario. An iOS application must be installed manually on 10 registered test devices. The team will use ad hoc distribution and will not publish the build through the App Store or test flight. Which two actions are required? Select exactly two answers. The available options are as follows. Option A. Register each device UDID in the Apple Developer Portal. Option B. Enroll every device in Microsoft Intune. Option C. Publish the application as a public App Store release. Option D. Install a certificate issued by the company's internal certification authority on each device. Option E. Produce and privately distribute an ad hoc signed release that includes the registered devices. Option F. Create an Intune device compliance policy. The correct answers are Option A. Register each device UDID in the Apple Developer Portal, and Option E. Produce and privately distribute an ad hoc signed release that includes the registered devices. Here's why. Ad hoc iOS distribution requires the test devices to be registered in the developer account and included in the provisioning profile used to sign the privately distributed build. Why are the other options not correct? B. Intune enrollment is not required for Apple ad hoc provisioning. C. A public App Store release violates the private testing requirement. D. An internal CA certificate cannot replace Apple code signing and provisioning. F. An Intune compliance policy is unrelated to creating an installable ad hoc build. Exam tip. For ad hoc iOS testing, register device UDIDs and sign the build with an ad hoc provisioning profile. Question number 204. Scenario. A delivery pipeline provisions a fleet of Windows Server virtual machines. The platform team requires declarative infrastructure deployment and continuous assessment or remediation of guest configuration drift with minimal manual configuration. Which solution should the team implement? The available options are as follows. Option A. Bicep templates and Azure machine configuration assignments. Option B. YAML stage templates and deployment group tags only. Option C. ARM templates and one-time custom script extension commands. Option D. Deployment jobs and manually maintained PowerShell scripts. The correct answer is option A, Bicep templates and Azure machine configuration assignments. Here's why. Bicep declaratively provisions the Azure resources, while Azure machine configuration assesses and can enforce the required guest operating system configuration across the VM fleet. Why are the other options not correct? B. Stage templates and deployment group tags organize pipeline execution but do not enforce VM desired state. C. Custom script extension performs imperative commands and does not continuously manage drift by itself. D. Manually maintained scripts increase administration and do not provide a declarative compliance model. Exam tip. Use infrastructure as code for resource provisioning and a desired state service for guest configuration and drift control. Question number 205. Scenario. A DevOps engineer must automate the deployment of Azure infrastructure using a Bicep file. The deployment will run from an Azure Pipeline's YAML pipeline using secretless authentication. Select and arrange the 3 required actions in the correct order to implement the solution. The available items are as follows. Item 1. Add an Azure Resource Manager template deployment at 3 tasks to the pipeline and reference the Bicep file. Item 2. Create an Azure Resource Manager service connection using Workload Identity Federation. Item 3. Configure an Azure Machine Configuration Policy. Item 4. Author the infrastructure definitions in a main Bicep file. Item 5. Store the Bicep file in Azure Key Vault. The correct sequence is 1. Author the infrastructure definitions in a main Bicep file. 2. Create an Azure Resource Manager service connection using Workload Identity Federation. 3. Add an Azure Resource Manager template deployment at 3 tasks to the pipeline and reference the Bicep file. Here's why. The Bicep file containing the desired infrastructure state must be created first. A Workload Identity Federation service connection is required to provide secretless authentication. Finally, the pipeline task uses the service connection to deploy the authored Bicep file to Azure. Exam tip. The Azure Resource Manager template deployment at 3 tasks natively supports deploying Bicep files without requiring a prior manual compilation step to ARMJSON. Question number 206. Scenario. A company builds container images in Azure pipelines and stores approved images in a private registry. Known vulnerabilities must be identified before deployment, and stored images must be reassessed when vulnerability intelligence changes. Which scanning strategy should the company implement? The available options are as follows. Option A. Scan images during continuous integration and periodically rescan images in the registry. Option B. Scan only running production containers after deployment. Option C. Perform a manual security review during project planning and another after release. Option D. Scan images only in the deployment stage and periodically inspect production containers. The correct answer is option A. Scan images during continuous integration and periodically rescan images in the registry. Here's why. CI scanning exposes vulnerabilities before an image is promoted, while registry rescanning identifies newly disclosed vulnerabilities in images that were previously built and stored. Why are the other options not correct? B. Production-only scanning detects issues after exposure and does not shift detection left. C. Manual reviews are slower, inconsistent, and not integrated into the application lifecycle. D. Deployment stage scanning is later than CI, and scanning only running containers does not continuously reassess the registry inventory. Exam tip. Scan container images both before promotion and after storage because vulnerability intelligence changes over time. Question number 207. Scenario. A Java team uses Azure pipelines and wants code quality findings and technical debt to influence release decisions. Quality analysis must occur during continuous integration, and releases must not proceed until the reported quality status has been reviewed. Which 2 actions should the team implement? Select exactly 2 answers. The available options are as follows. Option A. Add a post-deployment approval after production deployment. Option B. Integrate SonarQube analysis with the build pipeline. Option C. Require a pre-deployment approval that reviews the code quality result. Option D. Integrate the project with Azure DevTest Labs. The correct answers are option B, integrate SonarQube analysis with the build pipeline, and option C, require a pre-deployment approval that reviews the code quality result. Here's why. SonarQube identifies code smells and technical debt during the build. Reviewing the resulting quality status before deployment prevents unacceptable debt from progressing into the target environment. Why are the other options not correct? A post-deployment approval occurs after the release has already reached the environment. D. Azure DevTest Labs provisions test environments and does not analyze source code technical debt. Exam tip. Generate quality findings during CI and evaluate the quality gate before deployment, not after release. Question number 208. Scenario. An ASP.NET Core application loads its configuration from Azure Key Vault by using the Key Vault configuration provider. A legacy Key Vault access policy will be assigned to the application's identity. Which secret permissions are required while maintaining least privilege? The available options are as follows. Option A, list only. Option B, get and list. Option C, get only. The correct answer is option B, get and list. Here's why. The configuration provider enumerates the available secrets and retrieves their values, requiring both list and get secret permissions under a Key Vault access policy. Why are the other options not correct? A. List can enumerate secret metadata, but cannot retrieve secret values. C. Get can retrieve a known secret, but does not allow the provider to enumerate the secrets it must load. Exam tip. A configuration provider that discovers and loads multiple Key Vault secrets commonly requires both list and get. Question number 209. Scenario. An Azure pipeline produces container deployment artifacts that must be installed on a privately addressed on-premises server. For the statement, select yes if the proposed design satisfies the requirement. Otherwise, select no. Statement 1. Run the deployment on a Microsoft-hosted agent and use download pipeline artifact to retrieve the files. Statement 1. Run the deployment on a Microsoft-hosted agent and use download pipeline artifact to retrieve the files. The answer is no. The task downloads files to the executing hosted agent, which does not automatically deploy them to the private server. Exam tip. The deployment agent must have line-of-sight connectivity to the target environment. Question number 210. Scenario. An Azure pipeline must deploy build outputs to an on-premises application server. A self-hosted Azure Pipelines agent is installed on that server. For the statement, select yes if the proposed design satisfies the requirement. Otherwise, select no. Statement 1. In the deployment stage, use publish pipeline artifact to transfer the previously built files to the target application directory. Statement 1. In the deployment stage, use publish pipeline artifact to transfer the previously built files to the target application directory. The answer is no. The publish task sends files to Azure Pipeline Storage rather than retrieving and deploying the build output. Exam tip. Publish artifacts in the producing job, download and deploy them in the consuming job. Question number 211. Scenario. Application artifacts produced in Azure Pipelines must be deployed to an on-premises Kubernetes cluster. For the statement, select yes if the proposed design satisfies the requirement. Otherwise, select no. Statement 1. Install a Helm agent in the Kubernetes cluster and add only a download pipeline artifact step to the deployment pipeline. Statement 1. Install a Helm agent in the Kubernetes cluster and add only a download pipeline artifact step to the deployment pipeline. The answer is no. The proposed agent type is invalid, and the artifact download step does not apply the release to Kubernetes. Exam tip. For private Kubernetes targets, run deployment commands from a reachable agent and explicitly execute Helm or Kubernetes tasks. Question number 212. Scenario. A retail engineering team hosts its production platform on Azure virtual machines. A reusable ARM template defines the virtual machines required for feature validation. The team needs an Azure pipeline to create a temporary test environment from that template and remove the environment after testing to reduce compute costs. Which implementation should the DevOps engineer select? The available options are as follows. Option A. Add Azure DevTest Labs tasks to the pipeline to create and delete a template-based environment. Option B. Keep a second set of staging virtual machines running continuously and update them with deployment scripts. Option C. Use an Azure Cloud Service deployment task to provision the virtual machines. Option D. Require engineers to run Azure CLI commands manually from Cloud Shell before and after every test cycle. The correct answer is Option A. Add Azure DevTest Labs tasks to the pipeline to create and delete a template-based environment. Here's why. Azure DevTest Labs supports reusable environments based on ARM templates, and pipeline automation can provision the environment for testing and remove it afterward to avoid paying for idle virtual machines. Why are the other options not correct? B. Continuously running staging virtual machines increases hosting cost and does not provide an ephemeral environment. C. Azure Cloud Services deployment tasks do not deploy the required ARM-defined virtual machine environment. D. Manual Cloud Shell execution does not satisfy the automation requirement. Exam tip. Use an automated, disposable test environment when infrastructure must be recreated consistently and idle resource cost must be minimized. Question number 213. Scenario. A large application contains utilities and domain components that are reused by several teams. The organization plans to extract the reusable code into independently maintained packages. Select and order the 3 actions that should be performed to identify and establish ownership of the shared components. The available items are as follows. Item 1. Rewrite every component in the language used by most of the application. Item 2. Assign a responsible owner to each resulting component group. Item 3. Create a dependency graph for the application. Item 4. Determine which programming language occurs most frequently. Item 5. Group components that have related responsibilities and dependencies. The correct sequence is as follows. First, create a dependency graph for the application. Second, group components that have related responsibilities and dependencies. Third, assign a responsible owner to each resulting component group. Here's why. A dependency graph first reveals coupling and reuse. Those relationships support defensible component groups, after which each group can be assigned to a responsible maintainer. Exam tip. Define package boundaries from dependency and cohesion information before assigning long-term ownership. Question number 214. Scenario. A deployment pipeline provisions an Azure application by using an ARM template. Database passwords and connection strings must be resolved during deployment without placing their values in the template, parameter file, repository, or deployment operator's input. Where should the sensitive values be stored? The available options are as follows. Option A. An Azure storage table. Option B. Azure Key Vault. Option C. The application's appsettings.json file. Option D. An ARM template parameter file committed to the repository. Option E. The application's web.config file. The correct answer is Option B, Azure Key Vault. Here's why. Azure Key Vault provides controlled secret storage and allows an ARM deployment to reference protected values without placing the plaintext values in source-controlled deployment files. Why are the other options not correct? A. An Azure storage table is not designed as a protected secret store. C. Appsettings.json can expose secrets in application files or source control. D. A committed parameter file would store the sensitive values with the deployment artifacts. E. Web.config is an application configuration file and is not an appropriate central secret management service. Exam tip. Keep deployment secrets in Key Vault and pass references rather than plaintext values through infrastructure as code files. Question number 215. Scenario. A pipeline compiles a service by using a containerized build toolchain. The production container must contain only the runtime and compiled application so that the image is small and includes as few exploitable tools and libraries as possible. Which Docker build approach should the team implement? The available options are as follows. Option A. A single-stage build that retains all compilers and package managers. Option B. Docker Swarm orchestration. Option C, a multi-stage build. Option D, PowerShell desired state configuration. The correct answer is option C, a multi-stage build. Here's why. A multi-stage Docker file uses one stage for compilation and copies only the required runtime output into the final stage, reducing image size and excluding build tools from production. Why are the other options not correct? A single-stage build commonly leaves compilers, caches, and package management tools in the final image. B. Docker Swarm controls container orchestration and does not optimize image contents. D. PowerShell DSC manages configuration state and is not a Docker image construction strategy. Exam tip. Use separate build and runtime stages so the final container contains only production dependencies and artifacts. Question number 216. Scenario. A classic Azure release pipeline receives application builds faster than its test environment can deploy them. When several releases are waiting, the team wants the environment to deploy only the newest release and discard the older queued releases. Which stage configuration should be used? The available options are as follows. Option A, pull request triggers. Option B, release gates. Option C, deployment conditions. Option D, deployment queue settings. The correct answer is option D, deployment queue settings. Here's why. Classic release stage deployment queue settings include an option to deploy the latest release and cancel older queued releases when builds arrive faster than the environment can deploy them. Why are the other options not correct? A. Pull request triggers determine when validation or pipeline execution starts and do not manage queued releases for an environment. B. Release gates evaluate external conditions before or after deployment, but do not discard superseded releases. C. Deployment conditions control when a stage is eligible to run, not which pending release is retained in the queue. Exam tip. Use queue behavior to control competing releases. Use gates and conditions to control deployment eligibility. Question number 217. Scenario. A maintenance team is migrating an automated release pipeline from Helm 2 to Helm 3 for an Azure Kubernetes Service, AKS, cluster. The pipeline uses the Helm deploy task to release an application. Which architectural change must the team account for when moving to Helm 3? The available options are as follows. Option A. Helm 3 requires a dedicated Azure Container Registry agent installed in the cluster. Option B. Tiller is no longer required and should be removed from the Kubernetes cluster. Option C. The Helm client must be installed directly on the AKS control plane nodes. Option D. Helm 3 deployments require a mandatory Azure Service Fabric integration. The correct answer is option B. Tiller is no longer required and should be removed from the Kubernetes cluster. Here's why. Helm 3 eliminated Tiller, the server-side component used in Helm 2. Helm 3 operates entirely client-side and relies on the standard Kubernetes API and role-based access control, or BAC, configured via the deployment environment's kubeconfig. Why are the other options not correct? A. An ACR agent is not a Helm 3 requirement. Kubernetes pulls images using its standard container runtime integrations. C. The Helm client runs on the Azure Pipelines agent, not directly on the managed AKS control plane. D. Service Fabric is a separate orchestration platform and is completely unrelated to Helm and AKS. Exam tip. Remember that Helm 3 removed Tiller to improve security and simplify our BAC by relying purely on the Kubernetes API. Question number 218. Scenario. A customer portal records production exceptions. Operations requires an automated workflow that runs once each day, summarizes the recorded exceptions, and posts the summary to a Microsoft Teams channel. Which two Azure services should be included in the solution? Select two answers. The available options are as follows. Option A, Azure Pipelines. Option B, Azure Logic Apps. Option C, Azure DevOps Projects. Option D, Application Insights. Option E, Visual Studio App Center. The correct answers are Option B, Azure Logic Apps, and Option D, Application Insights. Here's why. Application Insights collects and queries application exception telemetry. Azure Logic apps can run on a recurrent schedule, retrieve or process that telemetry, and post the resulting summary through a Microsoft Teams connector. Why are the other options not correct? A. Azure Pipelines is intended for build and deployment automation rather than scheduled operational exception reporting. C. Azure DevOps Projects is not the telemetry source or workflow service required for the notification. E. Visual Studio App Center is not the appropriate source for server-side web application exception telemetry in this design. Exam tip. Combine an observability source with a workflow or integration service when telemetry must be summarized and delivered automatically. You have completed Part 5 of the AZ-400 practice series. Continue your preparation by opening the complete playlist and watching the remaining parts in sequence. Please like this video, subscribe to Tech with Kaushik, and enable notifications for more certification exam preparation content. Share your score, questions, or feedback in the comments. Thank you for watching. See you in the next part.